Friends, in my previous video I explained you LTI system output is nothing but a convolution of input with impulse response of the system. Output of the LTI system follows the rule. What is that rule? It is a convolution of x of n with h of n, where x of n is the given sequence and h of n is the impulse response of the system, and then that convolution can be written as summation x of k into h of n minus k. So this is the equation of convolution sum. Convolution sum in discrete domain it is called convolution sum, and here in continuous domain we say it is convolution. The corresponding equation, if you try to write in continuous domain, it will be yt. Instead of summation there will be convolution. Instead of it is a discrete signal, it will be a continuous signal, h of t minus tau. T is a continuous time variable, t is a real variable, it takes all values, and d tau. So x tau into h of t minus tau d tau, and limit is decided by your both impulse response and input of the system. So this is in continuous domain and this is in discrete domain. Now just verify whether this in this system or this equation, whatever we followed, whether it is satisfying or not. So we said that y of n is h of n when input is del of n. So let us try that, whether this equation is truly giving that or not. X of k h of n minus k. Right? Let us put x of n is equal to del of n. Obviously we should get y of n equal to h of n, because by that assumption only we derived this equation. Now let us put x of n equal to del of n. Since here x of k is there, so I will put del of k into h of n minus k. Okay, so here what will be your output? Y of n. We know that del of k will be having value 1 when k equal to 0. Otherwise del of k is 0. Though your summation is taking all values of k, let us say k is varying from minus infinity to plus infinity, but del of k is existing at one point. Existing means it has non-zero value at k equal to 0. So all other values of k, del of k is 0. Thus there is a summation. The summation is of no use, because k equal to 0 only summation carries value. Otherwise summation has 0 value, because for other value of k, del of k is 0. So k equal to 0 it is 1, and k equal to 0 h of n minus k becomes h of n. So whatever I was telling, when input is del of n, then output is h of n. So let us say we have told that, or I said that it is a time invariant system. So let us take the shifted input. Okay, so x of n, let us take x of n is del of n minus n naught. Input is shifted, then output, corresponding output should also shift. Del of n, what was the response? H of n. What will be the response for del of n minus n0? I am just shifting the input. That impulse response should shift. It should shift by n naught. So let us see what will happen. So put your x of k. What is x of k? X of k is del of x of k, del of k minus n naught into h of n minus k. Now just we have to see when del of k is changing, right? K is taking all the values, minus infinity to plus infinity. Let us say it is not given, so let us say it is taking all the values. Only that value of k, del of k minus n0 is non-zero. Which is that value of k? When k takes value n0, that time this becomes 0. Okay, when k takes value n0, that time this becomes this argument becomes 0, and del 0 becomes 1. Del 0 is 1, and when k takes n0, what happens here? When k is n0, it is 1, and k is n0, it is h of n minus n0. Now this is verified. So if you shift the input, output will also get shifted. So this is which we have assumed while deriving this equation. Now let us do something different. Let us take Hn and del n. So sorry, hn and xn, both the things are given to you. X of n is, let us say, del of n, and h of n is equal to del of n minus n1. Okay, these are the things given, both the things are given. Now what is the output? We'll put these inputs, whatever, these are the things which are given to us. So here if I put x of k will be del of k, and h of n minus k I am not putting, I will put later on. I am putting only first thing, x of n equal to del of n. So if you see here, k equal to 0, what is the output? H of n. And what is h of n? It is del of n minus n naught. So what is the meaning of this? If we convolve del of n with del of n minus n1, del of n convolve with del of n minus n1, then what is happening? There is a, right, what is happening? Del of n minus n1. Del n convolve with anything, you get the same thing. So what is this actually? This is the result of what? This is the result of x of n convolve with h of n. So what was x of n? X of n was del of n. And what was h of n? Del of n minus n1. So what is the result we got? Del of n minus n1. So it means that del of n convolve with anything, we get the same thing. So del of n minus n1. Let us take the signal, both the signals are shifted. X of n is also shifted impulse, and h of n is also shifted. X of n equal to del of, let us say, n minus n naught, and h of n is equal to del of n plus, let us say, n plus n1. What is that it is going to give? So again, y of n will be what? Del of n minus n naught convolve with del of n plus n1. So let us put, as I told you, I am putting for only x of k. X of k is del of k minus n naught. K minus n naught. I am putting the value of only x of k. H of n minus k I will keep as it is. Okay. So now here I know that k equal to n0. That time only this is non-zero. K equal to n0, it becomes h of n minus n0. H of n minus n0. But we know what is h of n. H of n is del of n plus n1. N is replaced by n minus n naught. N is replaced by n minus n naught. What happens? N minus n naught plus naught. So what you get? H of n is replaced by n minus n naught plus n1. So it was del of n minus n0. So minus n0 plus n1. Minus n0 plus n1. If it would have been minus, then it would have taken as h of n. It would have, okay, result in minus in bracket n0 plus n1. So simply we can say that if we convolve del of n minus n naught with del of n minus n1, so what we get is addition of those shifted, these shifts, whatever shifts, constant n0 and n1, addition of those constant with minus sign, n minus n0 plus n1, right? So if I take like this, suppose let us say this is again yn, and so yn is equal to this. If I take del of n plus 2 convolve with del of n minus 2, what happens? So here also what I am doing here, whatever is there, what is your n naught? Let us say n naught, my n naught is minus 2, del of n minus n naught minus 2, and what is del of this is n1, it is plus 2. So what is the result? n0 plus n1, result is what? So result is del of n. So del of n plus 2 convolve with del of n minus 2, the result is del of n. So similarly you can have convolution of y of n. Let us say your x of n is del of n minus n0 plus del of n plus n1. This is my x of n, and let us say h of n is given as del of n minus n2 plus del of n minus n plus n3, something like this. So what we have to do is this this convolution is a associative operator, okay, and here what we can do is see the first take this bracket, convolve with this function, take this bracket, convolve with this function. So we know that del of n minus n naught and del of n minus n0, right, these two, convolution of this with this, that gives me both are minus, so del of n minus in bracket addition, right, n0 plus n1, both are negative, so here negative, right. So del of n plus n1 here, del of what I am writing, n minus, see what is negative, negative is n naught, so here n naught minus n1, right. So by what we can write is del of n minus n0 plus n1. So this with this and this is n2, so it is n2, this is n2, I am operating with del of n minus n2, so it is del of n minus n0 convolve with del of n minus n2 is minus n0 and minus n2, so n0 plus n2 with minus sign, right, del of n plus n1 and del of n minus n2, so it will be n2 minus n1, n2 minus n1, right. So you can see here this sign also I am taking with this one, n minus n2 with this, n minus n2 with this, right. So that was mistake there. Now I will be taking, right, here n2 n0, n2 n1, both are over. Now let us take this n plus n3, what will happen, del of n, I can write like directly minus n0 plus n3, right. Then if I take this with this, I can write directly del of n n0 n1 plus n3. So this is your y of n, this is your y of n, okay. So whatever we have seen here is what I am saying is n minus n naught convolve with del of n minus n1 convolve with, let us say, del of n minus n2. There are systems, this is the input and passed to this system, I am getting some output, that output is passed to this system, you can see like, we can say like that way. So y of n, so del of n minus n naught and del of n minus n1 convolution is del of n minus n0 plus n1. So this is the output of, this is the input, let us say, this is the impulse response, output is like this. Now convolve with del of n minus n2, so what we get, del of n minus n0 plus n1 plus n2, this is your y of n, this is your y of n. So you can have number of system in series, cascaded in series, so there will be a convolution of impulse responses, their impulse responses. Now let us say sometimes you are given output, relation between input and output, relation between input and output is given, let us say y of n is equal to x of n plus 2 times x of n minus 1, something like this is given, and it is told that find the impulse response of the system. So we know that impulse response of the system can be obtained by putting xn equal to del n. When I put xn equal to del n, output becomes hn. So find the impulse response of the system, in this case find the impulse response, that is a question. So what is h of n? What is impulse response? So impulse response can be obtained, we know that to find the impulse response, put x of n equal to del of n, so y of n becomes h of n. So y of n becomes h of n. What I am saying, when I put x of n equal to del of n, implies y of n is equal to h of n. This is right, what is, we have seen this just now. So h of n becomes del of n, x of n is del of n 2 times del of n minus 1. So x of n is h of n is existing, h of n is non-zero at n equal to 0, h of n is non-zero at n equal to 1. So what is h of n? H of n is n equal to 0, this is del 0 and this is del minus 1. Del minus 1 value is 0, del 0 value is 1. Here n equal to 1, this is value at 0, n equal to 1, del 1 is 0, 2 times del 0, so it is 2. So h of n is this is your h of n. So we know the output, relation between input and output. That relation between an input and output is, this equation is called difference equation. In case of continuous time system, we are having differential equation. In case of discrete time system, the counterpart is difference equation. This equation is called difference equation. Difference equation. What this equation does? This equation gives the relation between input and output.